everyone, I'm Ying.
And I'm Eileen. Today we'll be sharing about programmable logic device.
Please enjoy our video.
Thank you. A programming logic device, also known as a PLD, is an integrated circuit consisting of arrays of AND gates and OR gates, which is programmable to perform any number of functions. Unlike the fixed logic device, which has a fixed function, a PLD has no defined function and it must be reconfigured to suit the requirement of the system.
There are three common types of programmable logic device. They are the SPLD, which is the simple programmable logic device, the CPLD, which is the complex programmable logic device, and lastly is the FPGA, which is the field programmable gate array. There are several advantages of the programmable logic device. Firstly is the ease of design. The support tools available for use in designing with PLD greatly simplify the design process by making the lower level implementation easier. In a matter of 1 or 2 hours, a first-time PLD user can learn to design with a PAL device, program it, and implement the design in the system. Design tools provided by manufacturers provide the convenience of programmable logic to customize a standard off-the-shelf products. Hence, PLDs are able to suit a wide range of speed and power requirements. Next is the performance and reliability. With the use of programmable logic circuits, lesser chips are required in order to build a complex system. With lesser units of components and board space, PC boards are laid out less densely, which would increase the reliability of the board. Besides, sources of noise in the system can be lowered, resulting to a cleaner and more efficient system. Thus, the implementation of programmable logic approach contributes to an increase in the system reliability. The next advantage would be the control of inventory. The use of programmable logic device also allows customer to control the material inventory. For electronic producers, these businesses are able to request for the specific amount of circuits needed, avoiding shortage of excess of logic devices in the inventory system. Lastly is the cost savings. A single PLD can replace several discrete chips and board space requirements can drop up to 25% or more when PLD are used. On top of that, these circuits can be used to suit requirement changes, hence reducing the need to stock up on other types of chips. Also, with the security bit features in the PLD, the design is protected and this avoids competitor from copying the design.
This is a video on the FPGA, which is the field programmable gate arrays. It is actually a silicon chip that has reprogrammable digital circuitry, and each of these FPGA has a number of configurable logic blocks on it. And there can be up to like 1,000 of these blocks on the FPGA. Between the blocks, you can have reconfigurable wiring circuitry which connects it together. So basically, you configure these logic blocks in any given configuration for any application that you need. And you can also dedicate certain parts of the FPGA for another task. So this allows one part of the FPGA to do something and another part of the circuit configuring something else. This is an important part for single point control applications. For example, these are I/O pins around the FPGA chip to interface each of the digital circuit with the outside world. And we can drive the top part of the circuit with an analog signal. Imagine this analog signal, we can run it through an analog to digital converter and then drive that analog signal directly into the chip. And single processing processes such as the filtering process can be done. The filter signal can then be sent to the output pins to a digital to analog converter, and then the filtered signal can be sent to the outside world. This marks the end of our video. Thank you for watching.